This is the second video on section 4.9. In this video, I'll give you a short introduction to differential equations. So what is a differential equation? Well, a differential equation is an equation that involves derivatives and whose solution is a function that makes the equation true. So this is different from a sort of traditional equation where the solution is a number that makes the left-hand side equal the right-hand side. For a differential equation, we're going to be looking for a function that makes the left-hand side equal the right-hand side. So an example here is that the function y equals 1/2 plus 5e to the minus x squared is a solution to the differential equation y prime plus 2xy equals x. So let's check and make sure that this is a solution. So what we're going to do is we're going to plug in the y function that we gave. We're going to plug that in for y, and then the y prime, we're going to figure out the derivative, and we're going to plug that in there. And then what we're going to try to figure out is whether the left-hand side equals the right-hand side, no matter what x is. So we're not going to plug anything in for x. We're going to leave the x as an x. So the y prime, that's going to be the derivative of 1/2 plus 5e to the minus x squared. 1/2 is a constant, so the derivative of 1/2 is 0. 5 is a constant multiple. For the derivative of e to the minus x squared, we're going to need the chain rule. The derivative will be e to the minus x squared multiplied by the derivative of minus x squared, which is minus 2x. So that's the y prime. So if I'm trying to match this up with my differential equation, there's this whole business. That's my y prime. And then plus 2xy, so plus 2x, and then the y is the function that we were given. So 1/2 plus 5e to the minus x squared. And the question is, does that actually equal x? And again, the idea here is that that should equal x no matter what x is. So what we have to do is simplify the left-hand side and see if we can get this to work out. So 0 doesn't do anything, and then we've got 5 times the negative 2x, that's going to be negative 10x, multiplied by the e to the minus x squared. 2x times 1/2, so I'm distributing here. So 2x times 1/2, that's going to be x, and then 2x times 5 is 10x times e to the minus x squared. And then this whole thing cancels out with that whole thing, and x equals x, so this checks out. So we can tell that a function is a solution to the differential equation by plugging in and checking, but the trickier part is actually finding the solution in the first place. So we can classify differential equations into different types, and when we do that, the different types of differential equations, each type is going to be solved in a similar fashion. And the simplest type, which is all we're going to talk about in this class, is going to be differential equation that has the form y prime equals and then an expression that only involves x's. Because if we know what y prime actually equals, then we can figure out y by taking an antiderivative. So y here is going to be the antiderivative of whatever that expression was. So let's do an example. So suppose we want to solve the differential equation y prime equals 2x plus 10. Well, then y is going to equal the antiderivative of 2x plus 10. Right? Because what this equation is saying is this is saying the derivative of y, that's what y prime is 2x plus 10, and then the question is, what's y? And this is exactly the antiderivative question that we were talking about in the previous video. I know what the derivative is. I'm trying to figure out the original function. The way that I do that is with antiderivatives. So we learned how to do antiderivatives last time. The antiderivative of 2x is x squared. Antiderivative of 10 is going to be 10x. And then because we're taking an antiderivative, we get a plus c. So this would be the solution to my differential equation. Now, anytime we do this kind of differential equation solving and we take an antiderivative, we're going to get a c. We're going to get a plus c. But the only way we're going to be able to figure out what the actual value of c is, the only way we're going to get an actual number there, is if we have a little bit of additional information. And when we have that additional information with our differential equation, the whole thing is called an initial value problem. So let's do an example of an initial value problem. In this case, we're given that f prime of x is x squared minus 2x, and this additional information, this is called our initial value. So we're given one value of our function, and we're going to be able to use that to figure out c. So the way we're going to solve this is, for the moment, we're going to put aside that initial value. We're going to forget about it for the moment. We'll get back to it in a minute. And again, this is telling me that the derivative of f of x is x squared minus 2x, and the question is, what's f? right? Because if we're saying solve a differential equation, or in this case, solve an initial value problem, the solution is the function. Well, if I know the derivative, then the way that I find the original function is I take an antiderivative. So this is going to be the antiderivative of x squared minus 2x. Again, using our rules that we learned in the previous video, that's going to give us 1/3 x cubed by my power rule. Antiderivative of 2x is x squared, and then we get a plus c. And if we didn't have the initial value, that's as far as we would be able to go. There would be no way for us to figure out what that c is. But because we know that f of 1 is supposed to be 1/3, we can take this initial value and plug in 1. Why are we plugging in 1? Well, because they told us what f of 1 is. So that's the number that we want to plug in. If they had told us what f of 5 was, we would be plugging in 5. So f of 1, according to my formula, is going to be 1/3 times 1 cubed minus 1 squared plus that mysterious c, and somehow that's supposed to work out to be 1/3. So let's figure this out. We get 1/3 minus 1 plus c equals 1/3. That's going to be negative 2/3 plus c equals 1/3. Add 2/3 to both sides, and we get c equals 1. So the final answer here now is to take our function that we figured out, f of x, and put in what we've learned, which is that the c is equal to 1. So our final answer is 1/3 x cubed minus x squared plus not c anymore. Now I know it's 1. So that's going to be my answer to this initial value problem. So that's the idea. So for the kinds of differential equations that we're going to talk about, all you're going to need to do is take the antiderivative. And if you happen to have an initial value, then you plug in that initial value and figure out what the value of c is.